Hello, welcome. Let's try to solve another Leetcode problem. 1533. Find the index of the large integer. So for this problem, we are giving an API, but not this kind of array. Yeah, but let's just understand the problem according to this array. So definitely inside the array, there's gonna be a number which is gonna be different from all other numbers. So this number is going to be the largest number, and there's only one largest number, which is going to be 10. Yeah. So inside of this example, we're going to have 7, 7, 7, 7, and 10, and other 3 sevens. Yeah. So we just want to find this integer. Yeah. Because actually, for some of the problem, they are giving us such kind of API, and then it gives us an array. Actually, we don't need to understand anything about the API because we can directly use it to call the API. Yeah. So now let's just analyze the problem as an array instead of API. Yeah, because we can use all the possible methods for this array, and we're gonna use two methods. One is the length, and according to this length API, reader.length, definitely we can get the length of the array. Yeah. And also we can use a compare sub. So this is another method. So this means we can compare the value from index from L to R. So for example, this is L and this is R. Yeah, we can compare the value from L to R, or we can compare the value from X to Y. Yeah. So this is very important for us because if we don't have such kind of method, definitely we cannot solve it by using only 20 times of code this. Yeah. Because of this one, definitely we're gonna call this one 20 times. So this means we're gonna use a boundary search. Yeah, basically this is a 10 to the power of 5. If we use if we were to make it 20 times of coding the method, definitely we're gonna use a log of 10 to the power of 5. So it's gonna be less than and equal to 20. Yeah. So this means we're gonna use a boundary search. Yeah. So the idea is that we're gonna prepare an L and R pointer. So L gonna be equal to 0. R gonna be equal to n minus 1. Yeah. And then we're gonna check the midpoint. So what gonna be the midpoint? So what gonna be the length of the array? 1, 2, 3, 4, 5, 6, 7, 8. So the length of the array is 8. So 0 plus 8 divided by 2, it's gonna be at index 4. Yeah. So this gonna be at index 4, which is gonna be this value 10. Yeah. So if we find the index, what are we gonna do? Definitely we're gonna use a boundary search to find. Yeah. So currently, because the length of the array is 8, and this is the left side. Yeah. We're gonna have a 4, 7. It's gonna be 28. At the right side, it's gonna be 10 with the 3, 7. So it's gonna be 31. Yeah. Because at the right side, it's gonna be bigger than the left side. So this means we're gonna use a boundary search. So we're gonna reset the pointer. So after resetting, this is gonna be the L pointer, and this is gonna be the R pointer, and then yeah, we only check the right side, this side. Yeah. Now because we're gonna check the midpoint, so because this is a 0 and 3, 0 plus 3 divided by 2. Yeah. So it's gonna be at index 1. Yeah. So it's gonna be here. So now we're gonna compare 10 plus 7 with 7 and 7. So because 10 plus 7 is bigger than 7 plus 7, so definitely it means inside here it's gonna have the maximum value. So the L pointer and R pointer are gonna be updated once again. So currently, yeah, this is the L pointer. We only left behind is 10 and 7, and this is the L pointer, and this is the right pointer. And we're gonna continue to use the boundary search. So definitely we're gonna find this value, which is gonna be 10. Yeah. So if you don't believe it, let's just run the function once again. So this is L and this is R, and we're gonna find the midpoint. It's gonna be L plus R divided by 2, so it's gonna be at L. So this is gonna be the midpoint. Yeah. Now we're gonna check because there are only two numbers. We're gonna check the left side and the right side. Yeah. Because at the left side it is 10. 10 is more than 7, so the R pointer gonna be shifted to the same place as L pointer. Yeah, because R equal to L and this is 10, definitely we can find the answer by using the boundary search. Yeah. Now let's just try to use the boundary search to solve the problem. Yeah. So we're gonna prepare L and R pointer. L gonna be 0. R pointer we can use the API. It's gonna be reader dot length. Yeah. -1. So this is gonna be L and R pointer. And then we can write the boundary search. So m gonna equal to L plus R divided by 2. Yeah. So before we are using the boundary search, we have to check if the length of the array is even or odd, because it's gonna be different. So let's just check some different cases. So for example, if we have something like 7, 7, 10, and 7, 7, yeah. So for this array, there's going to be a value of 10. We're going to find this value 10, and for the left and right pointer, this is L and this is R, and L is 0 and R is 4. So 0 plus 4 divided by 2 is going to be m. So m going to be this value and 10. Yeah, because of the length of the array is currently it is odd. Yeah. Yeah, since it is odd, so how we gonna compare? Yeah, because it is odd, so we're gonna compare with 3 values. So definitely it's gonna be L to m and m to r. Yeah, because for calling the function compare sub, it's gonna include the L and also include the r. So we're gonna compare with L to m and m to r. Yeah, according to this way, definitely we can find the value. Which one gonna be the value? Actually, it's gonna be this value on 10. Yeah, definitely we're gonna include this m if it is odd. So what about if it is even? So let's just check this case: 7, 7 with 10, 7. Yeah. So the length of the array is even. Now the L pointer and R pointer gonna be 3, and L pointer gonna be 0, and yeah, 0 plus 3 divided by 2 gonna be m. So m gonna be 1. So this is the m pointer. Yeah. Now what's gonna be the left side and what's gonna be the right side? So the left side is gonna be L to m, and the right side is gonna be m plus 1 to r. So this is the only difference. Yeah. Because for here, the left side is going to be L to m, and the right side is going to be m to r. So this is why we have to check if the array is even or odd. Yeah. Now we're gonna check the array. So if the length of the array, yeah, I didn't prepare. Yeah, let me think about it. So currently we calculated yeah, we need to this is L and this is R. We need to check if yeah, if the final value is even or odd. Yeah, so let's just use R minus L plus 1. So we're gonna use R minus L plus 1. That's gonna be the total numbers. Yeah, we're gonna check the total numbers to be odd or even. If it is a modular 2, so this means this gonna be, yeah, they're gonna be odd numbers. Yeah, so now we're gonna call this function. So it's gonna be the compare. So it's gonna be the reader dot compare with 4 different values. So it's gonna be L, M, and M, R. Yeah. So I'm gonna set this value to be result. Yeah. Now I can use boundary search. So if result equal to -1, so this means from L to M is less than M to R. So definitely we're gonna shift to the L pointer. So M gonna equal to so yeah, L gonna equal to M plus 1, and if result equal to +1, so the R gonna be equal to M minus 1, and else it's gonna be yeah, we're gonna return the value. Yeah, because they are equal. So from the left side equal to the value from the right side. Yeah, so definitely it means we find the value. So currently for this example, let's just check that. Yeah, so from the left side it is a 7, 7, 10. From the right side it is a 10, 7, 7, right? So it means from the left side gonna equal to the right side. Definitely this result gonna be equal to 0. So if it is 0, it means we've already found the answer. It's gonna be this m. So we're gonna return this m. Yeah. So this is one case. So another case is that if r minus l plus 1 can be odd, can be even. Yeah. So if it is even, let me just copy the same code. Yeah. So as I explained earlier, here gonna be l to m, and at the right side it's gonna be m plus 1 to r. And now, yeah, similarly we're gonna check if the result is -1. So l gonna equal to m. So currently we don't need to check if the left side is gonna equal to the right side, because definitely it's not possible. Yeah, because it is even. Let's check this example here. 7, 7, 10, 7. Is that possible? The left side is gonna equal to the right side. Definitely from here, because it is even, definitely it is not possible. So we don't need to compare here. Yeah. So now let me just delete the last one. Yeah. So the first condition is if result equal to -1, I'm gonna shift to the L powder gonna be equal to m plus 1. Yeah. So for example 7, 7 and 10, 7. Yeah. So this is the left side. It's less than the right side. It means the result is gonna be a -1. So I'm gonna shift to the L powder. L powder gonna be here. This is gonna be the R powder. Yeah. So if it is another case, so for example 7, 10 and 7, 7. Yeah. So the left side is going to be bigger than the right side. It means the result is going to equal to 1. If the result equal to 1, so this is the L powder, this is the R powder. So the R powder is going to equal to m. So this is going to be the R powder. Yeah. So here R powder is going to equal to m. Yeah. So this is the only difference. Yeah. Now let me just run it to have a. It didn't work. Yeah, because I didn't use double equal. Now let me tap here. It's gonna be the double equal. Now let me just run it. Yeah, now as you can see, it works. Now let me just submit it to prove that it can pass for all testing cases. Yeah, as you can see, it passes for all testing cases, and it's pretty fast. Because currently we are using the boundary search, they're going to be only less than 20 times of calls. At the time complexity, definitely it's going to be log n time. I think that's all about it. Thank you for watching. See you next time.